In this video we are going to look at calculations with moles. First we're going to look at the definition for moles, and then later we are going to look at some example calculations. When we talk about moles in chemistry, we don't talk about the furry animals that live underground. In chemistry, the mole is used to measure the number of particles in a substance. This can be atoms, molecules or ions. 1 mole always equals 6.02 times 10 to the power of 23 particles, and this number is called Avogadro's constant. This is the formula triangle that we need to use when we do calculations with moles. We have the mass at the top, and then we have AR or MR times moles at the bottom. Now AR is the relative atomic mass and MR is the relative formula mass, and you will have to decide which one to use depending on what you are given in the question. If you are given atoms, you use the relative atomic mass, and if you are given ions or molecules, you will have to use the relative formula mass. We also need to note that the unit for moles is MOL, and this is just read mole. So let us look at an example. Calculate the mass for 2 mole of nitrogen molecules N2. So now what we need to calculate is the mass, and we need to look at the triangle to find out how we can do this. So mass equals, if we cover up the bit with the mass at the top, we are left with AR or MR times moles. We're given molecules here, so we need to use MR, the relative formula mass. So we get mass equals MR times moles. When we look back at the question, we can see that we are given 2 mole for moles in the question. So we can just plug that 2 straight in. Now what we need to do is we need to calculate the relative formula mass, MR. And we do this by looking at the nitrogen molecule. We can see we have 2 nitrogens, so we need to look at the periodic table and find the relative atomic mass or mass number for nitrogen, which is the top number on your periodic table. Because we have 2 nitrogen atoms, we get 2 times 14, and that gives us a relative formula mass of 28, and we can now plug this into our equation. So we get 28 times 2, and this gives us a mass of 56 grams. Now we're going to look at a second example. Calculate the number of moles for 88 gram of methane, CH4. So now what we have to calculate is the number of moles. So we start by writing moles equals, then we need to cover up the moles on the formula triangle, and that leaves us with mass divided by AR or MR. Methane is a molecule, so we need to use MR, so we get moles equals mass divided by MR, relative formula mass. The mass is given to us in the question. We have 88 grams, so we can plug this straight into our equation. And then again we have to calculate the relative formula mass, MR. And this time we have 1 carbon, and the relative atomic mass of carbon is 12, so we get 1 times 12 plus, then we have 4 times hydrogen. The relative atomic mass of hydrogen is 1, so we get 1 times 12 plus 4 times 1, and this together gives us a relative formula mass of 16, which we can then plug into our equation. So now we have moles equals 88 grams divided by 16, and this gives us a number of moles of 5.5 mole. Now it is your turn. We're just going to look at the question really quickly. Calculate the mass of 0.1 mole sulfur dioxide, SO2. So now you can pause the video, grab a piece of paper, use the formula triangle and try to calculate the mass of 0.1 mole of sulfur dioxide yourself. In this question we have to calculate the mass, so we get mass equals mR times moles. Sulfur dioxide is a molecule, so we need to use mR, the relative formula mass. We have 0.1 mole given to us in the question, which we can plug in directly. And then we need to calculate mR again. So mR equals 32 for one sulfur atom plus 2 times 16 for 2 oxygen atoms. And this gives us a relative formula mass of 64, which we can now plug into our equation. So mass equals 64 times 0.1, and this gives us a mass for sulfur dioxide of 6.4 grams.